Hi, we're Shoulder Dislocation Team Number 2, and our team members are Rick, Will, Rebecca, and me, Gabe.
Currently, there are no products that allow medical students and doctors to simulate the process of reducing the shoulder dislocation. This forces medical workers to practice placing the shoulder back into its correct position on real patients, which is ineffective and can cause additional harm to the patient.
Because of this, doctors and medical personnel need a practice device to simulate the process of reducing a dislocated shoulder.
Our solution is a portable yet durable practice device that accurately simulates the anatomy of the shoulder joint so that reductions can be practiced.
Our final prototype can be split up into 4 design blocks: the bones, the muscles, the connections, and the body. The bones were based off scans from real bones. From these scans, 3D models were made for the scapula and the humeral head. The scapula was then printed with PLA and a 10% infill density, and then iterated upon in Fusion 360 in order to add support structures, a base, and a modified socket to hold the humeral head. This base has 4 holes that allow it to be bolted onto a wood block with 1/4-inch bolts, allowing the part to be easily replaced. The humeral head was printed using the same PLA material and infill density. To simulate the muscle forces on the humeral head, we simplified the forces down to 4 vectors and used Ranger bands to replicate the actual muscles. The front and back bands have strengths of 6.1 kilograms. The top band has a force of 5.5 kilograms. To connect and guide the bands from the humeral head to the body, we used eye hooks with diameters 14, 12, and 8 millimeters. These eye hooks are screwed into the wooden backplate and the humeral head. The body is made up of 2 components, the mannequin outer shell and the wooden backplate. The wood backplate is cut so they can fit inside the mannequin and is attached to it with screws. The entire body is 23 inches tall and 20 inches wide. We have also developed a replaceable shoulder pad that will allow the user to practice reducing a shoulder with and without seeing the internal anatomy.
This position is where the humeral head and scapula rest naturally. This is the position in which you wish to return the joint to once you have successfully reduced the shoulder. To dislocate the joint, you pull it out, down, and then forward. Once the shoulder is dislocated and in the correct position, you can begin to execute the reduction maneuver. In this example, I will show you the Milch maneuver, one of the most common reduction techniques. To begin, you further extend the injury by pulling the humeral head out. You then move the humerus or arm back to even with its original location. This specific movement path ensures that no muscles nor tendons are caught out of place. Finally, you place the shoulder directly back into the socket of the scapula.
Our final prototype successfully met all of our set design criteria. It passed our durability testing, which required it to withstand 30 trials per day for 30 days, or in other words, 900 dislocations and reductions. The final prototype cost was about $100 and was constructed well within our set budget of $250. In addition, it met our ease of use requirement and could be dislocated on average within 5 seconds, which was well within the 1-minute goal. Lastly, after consulting our client, who is an experienced doctor, our prototype met our expectations for anatomical realism, and after consulting additional instructors and peers, we concluded that our prototype also passed its aesthetics testing.
To complete our project, we are looking to increase modularity by making the scapula not only reproducible through 3D printing, but also easily replaceable through a series of bolts and screws. Additionally, we will continue to test our project with Dr. Teeling to make sure that our bands are the appropriate strength and model the shoulder realistically. To continue this, we will also be adding a series of eye hooks so that the strength of the bands can be changed to model different patients. We will be continuing our project next semester in the Engineering 190 course with Dr. Satterback.